Hello everyone, I hope you're okay and I hope the videos we keep uploading are helping you out. This is the fifth video whereby I'm tackling questions on electrostatics. Please note that guys, you should expect a total number of 13 questions uh, and all of them are extracted from past exam question papers. It's very important for you to know how to tackle such questions. I believe it will give you an edge whenever you write your exam. Even if you're doing grade 11, please stay with us over here guys, because grade 11s and grade 12 write one and the same thing when it comes to electrostatics. So do share the link to your peers as well now. Okay, we are told that 2-point charges P and S are placed at a distance which is 0.1 meters apart. The charge on P is 1.5 nanocoulombs. It's a positive 1.5 nanocoulombs, and the charge on S is a negative 2 nanocoulombs. And then a third charge, which is R, with an unknown positive charge, okay, this is positive, is placed 0.2 meters to the right of charge S as shown in the diagram below. First question, they want us to state Coulomb's law in words. It simply states that the electrostatic force between 2-point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance apart. 7.2, they want us to draw a labeled force diagram showing all the electrostatic forces acting on R due to P and S. Okay, since R is a positive force, okay, I want to see how does charge R behave as a result of both charge S and charge P. Okay, so if this represents charge R, firstly I want to know how does R behave as a result of charge S. Both of the charges have two different polarities. This one is positive, the other one is negative. Are you together? So there is a force of attraction between them, which simply means that R will move towards the left because of sphere S. Are you together? So this over here represents the force between S and R. Okay, and then now I want to see how does R behave as a result of charge P. Both of the charges are positive, so there is a repulsive force between these two charges, which simply means that R will be pushed away by charge P towards the right. So this is the force between charge P and charge R. Remember that guys, if ever you have a repulsive force, it simply means that your two charges are just pushing one another away. So P will try to push R towards the right. Are you together? And then now we are told that the magnitude of the charge, rather we are told to calculate the magnitude of the charge on R if it experiences a net electrostatic force of 1.27 times 10 to the power negative 6 newtons to the left. Take forces directed to the right as positive. They're telling us to take the forces directed to the right as positive, which simply means I have a positive here and this one will be negative. F net is equals to the sum of all the forces in one dimension, right? F net is just the force between S and R plus the force between P and R. Are you together? But since we are given the direction of our F net, I know that I have a negative F net, and then the force between S and R is to the left, so it's also negative F of S on R. Or rather, let me just substitute. Let me just write the equation. That's K QS and QR all over R squared plus K QP and QR all over R squared. And then I know that the magnitude is just 1.27 times 10 to the negative 6. That's 9 times 10 to the power 9. Sphere S is just 2 microcoulombs. Is it micro, nano? Nanocoulombs, man. I don't know the charge on R, but the distance between S and R is just 0.2 meters apart. And then plus 9 times 10 to the power negative 9. The charge there is 1.5. 1.5 times 10 to the power negative 9. This is positive 9, guys, excuse me. Multiplied by QR. The distance between the two, that's 0.1 plus 0.2. I'll simply get 0.3 squared. I still have negative 1.27 times 10 to the negative 6. I know that the product, let me just punch the calculator. I want to find the value of this part over there. Ne? So I'll simply substitute 9 times 10 to the power 9 multiplied by 2 times 10 to the power negative 9 all over 0.2 squared. So this will give me 450 multiplied by QR. It's a negative 450 rather, plus that's 9 times 9 to the power 9 multiplied by 1.5 times 10 to the power negative 9 divide by 0.3 squared. That's 150 multiplied by QR. So this is negative 1.27 times 10 is equals to negative 300 multiplied by QR. Divide both sides by negative 300. And then QR, the charge on sphere R, that's basically negative 1.27 times 10 to the power negative 6 divided by negative 300. This will simply give us 4.23 times 10 to the negative 9 coulombs. So the charge on sphere R is just positive. It's just positive 4.23 nanocoulombs. 4.23 times 10 to the negative 9 coulombs. That's how, guys, you're supposed to tackle that question over there, ne? And it's positive. Please remember that is positive, ne? Because I think we're told that point R is a positive point charge. Yeah. Point R is a positive point charge. So that's how, guys, you're supposed to tackle that question. Just stay tuned, guys, and wait for more videos. Thank you for your time.